All right, welcome to Tullips in Physics. So what we're going to do today is now we're going to launch a projectile at an angle off the ground. And this time we'll just have it return to the ground. It makes math just a little bit easier. But the process for figuring out what's going on with a projectile is the same in every single case. You're going to think about, okay, what's happening in the vertical direction? You know, there's acceleration involved because of the force due to gravity in the vertical direction only, because we're going to make the assumption that air doesn't matter. And so in the horizontal direction, the object is going to travel with a constant velocity. And so we can write up equations, kinematic equations based upon those situations. So let's say I have the ground here. Let me get my good old cannon that I had before, but now I'm going to shoot it upwards. Right? Ball's going to go through the air. And there's actually a couple things that we could solve about that. And so I drew it that way, didn't I? So okay, we can do that. Let's say that cannon is 1 meter off the ground. I was going to go ground to ground, but I drew it this way. Let's do this. And let's say the cannon, the angle here is 30 degrees. I don't have that drawn very well. And then similar to what we did in another case, let's say the initial velocity, and this is the total velocity, equals 20 meters per second. All right. So we're going to think about all of the stuff that possibly can go on. And I'm also going to think about my coordinate system, because now my coordinate system really matters. And in this particular case, I think what I'm going to do is I'm going to set the ground to 0, and I'm going to call up positive. And I'm going to call to the right positive too. So this direction's positive, but 0 is where the ball starts. All right. And so what I'm going to try to do is come up with a way to figure out how high does the ball go and how far down range does it go. And I could also figure out, well, how long is it in the air for as well. So I could do all those kind of things. And so where do I start? Equations of motion again. Now, what I'm going to do is I'm going to draw a velocity. So velocity is like this. I said it's 20 meters per second at an angle of 30 degrees above horizontal. So what does that actually mean? Well, I can actually divide this up into two components, and maybe I should be using a different color to do this. And so I can divide that up into horizontal and vertical velocity so that I can deal with them separately. And so here I'm going to have my initial velocity, which is 20 meters per second, and this is the cosine of 30 there. And here is the sine. It's the opposite side, right? And so sine is equal to 1/2. Sine of 30 degrees is equal to 1/2. So it turns out my vertical velocity, so maybe I call it v naught y, is 10 meters per second. And then I'm not so good with my other angle, so cosine 30 times 20. And so my initial velocity in the x direction is actually 17.32 meters per second. So I'm just going to keep that in the back of my mind as I'm solving up my problem solving for this. So now let's think about the problem solving for this. So let's do in purple. Let's do the harder one first. We're going to think about what is my general equation of motion. And I put y in there already. It's x on your formula sheet. Now I'm going to apply it to this situation, right? So what do I know in this situation? Well, I don't know where it is height-wise, so I'm going to say that's y. Now, because I said up is positive, I'm going to have to make this negative because g stands for 10, but I have to say it's in the downward direction. I don't know time, so I'll put time there. The initial velocity is actually this number, which I'm right now just going to write as v naught y times time. And then y naught, I suppose I could put it in. It's positive 1 meter. I'm starting 1 meter above the ground. Cool. All right, now let me grab blue for the x direction. So x is simple because there's no acceleration. So really it's just the second part of this equation since a equals 0. And I'm actually going to set x naught equal to 0. And so all that's left is the initial velocity, but it's just in the x direction, times time. And there we go. Those are my two equations, and so I can solve for this. So there's a couple of things that I want to solve for. So I could solve for time, right? So I could solve for time here, because actually what am I doing? I can actually substitute another number in here that I didn't do. Where does the ball end? It starts at 1 meter. Well, if it's going to hit the ground, well, this is actually 0, so I should have put a 0 there. Okay, let's rewrite this so that I can actually do quadratic formula with this. So minus 1/2 g, let's go ahead and use 10 for g. So that actually means minus 5t squared. And that has units. I should have wrote the units. Meters per second squared. Plus my v naught y is in the positive direction. And it's 10 meters per second t plus 1 meter. All right, and so what I need to do is I need to do the quadratic formula on that. And the good news is I have a quadratic formula calculator on my phone just to make life a little bit easier. And so my quadratic formula calculator, and you can Google one as well. So what I'm going to do is I'm going to put in minus 5 for A. I'm going to put in 10 for B, and I'm going to put in 1 for C, hit equals. And so what it tells me is I have a negative solution, which would be where would it hit the ground if I went backwards, so I'm not caring about that. What I care about is the positive solution. It gives me time equals 2.095 seconds. All right, so that's the time it's going to take to hit the ground. Well, now I can put that into here and calculate where will it hit the ground. All right, so x equals, v naught x is 17.32 meters per second, and it takes 2.095 seconds to hit the ground. Cool. All right, let's plug that into the calculator. So times 2.09, okay, and I get 36.29. So let's round that to 36.3 meters. So that's where it hits the ground, out here at 36.3 meters. Cool. All right. So I can actually figure out how long it's going to be in the air for, and I can figure out where it's going to hit the ground. But that's not all. There's one more thing I can calculate based upon all of this. And so the other thing I can calculate is how high did it actually fly through the air? Like if I had a building in here or something, could it go over the building or something like that? So how do I figure out how high it is? Well, here's the key at the top, right here. What's the velocity in the y direction? It's 0, right? That's the turnaround point. And so we can use that information to help us greatly. And what I'm going to do, actually I got room over here. I'll do it over here. Let's do it in green for colorblind people. But VF squared equals V naught squared plus 2AX is going to come to our rescue here. Why do I say that? The final velocity in the y direction is 0. The initial velocity in the y direction is 10. And so what this is going to tell us is it's going to tell us what delta x is. So delta x is not actually the height, it's the difference from 1 meter to the top. So if I want to know how far off the ground it is, I have to add back in 1 meter. So what I'm solving for is x. Well, technically y. So let's call it y in this case. So the delta y is going to equal VF squared minus V naught squared over 2A, just 2A. And so then the change in position, so like I said, the final is 0, negative 10 meters per second squared divided by 2, and this is actually negative 10 meters per second squared. All right, well, that's math's not too bad, right? Because a 10 and a 10, 10 divided by 2. So delta y is simply 5. Double check the math, cancel one of the 10s, then I got 10 divided by 2. Yeah, so that is correct. And so my actual height, though, because it's starting 1 meter off the ground, the actual height off the ground at its peak is 1 meter higher than that. So it's actually the high point, because I started above the ground, is a little bit higher. All right, so let's slide everything back on the screen so you can see it. So there's a number of different things I can do, but basic bottom line is I'm looking at an equation that involves acceleration in the vertical direction, which I indicated by y. I'm looking at constant velocity in the x direction, and what links the two things together? Time. Right? So I can actually do somewhat sophisticated analysis of projectiles as long as there's no air resistance. So just keep those basic principles in mind, keeping the y and x direction in this. Think about them separately because only one accelerates and one has constant velocity.